Thanks everyone for attending. I'm David Eoff, VP of Sales at Preferred Utilities. Today we're going to talk about the storage, handling, and use of biodiesel, and we'll get an update on the regulatory environment around biodiesel use. We will take your questions at the end of this presentation. You can email them to me or type them in the chat box. My email address is on every slide of the presentation. The most common question we get is, can I get a copy of the presentation emailed to me? The answer is yes. Just email me and I will reply with a copy of the PowerPoint presentation. Also, Megan will put this video on YouTube in a couple of days where it will go on and live forever. So, like a James Michener novel, we're going to start at the very beginning and explain what biodiesel is. So biodiesel is basically a blend of non-fossil fuel, vegetable oils, and animal fats for use in boilers, engines, and other combustion equipment. The standard for biodiesel is ASTM D6751. The exact blend will vary by batch, but the final result must meet ASTM D6751. And if you can't read that graphic on the screen, it says that biodiesel is typically made from 53% soybean oil, 7% canola oil, 10% distiller's corn oil, 11% animal fats, 13% recycled oils like recycled cooking oil, and 6% palm oil. But this can vary from batch to batch within the specification. These are biodiesel's physical properties. You can find a lot of information on biodiesel's chemical properties online. I'm a mechanical engineer and a combustion engineer, not a chemist, so I tried to stick to the physical properties that affect storage, handling, and combustion. I apologize for the metric units. Europe is way ahead of the US in biodiesel use, so most of the information you find on biodiesel is going to be in football units, not soccer. So why are people concerned about switching to biodiesel? People are really concerned about burning biodiesel and biodiesel blends, and you'll see in a few slides how biodiesel blends are being forced on a lot of people. Boilers and gensets are expensive, and people want to ensure they lead a long, happy, productive life. The first issue of concern with biodiesel is it is corrosive to metals containing brass, bronze, and copper. It is much less corrosive to carbon steel, and stainless steel resists biodiesel corrosion almost completely. The other concern is swelling of rubber seals and O-rings. If you don't get rid of your rubber components, they will swell and potentially cause problems. This affects pump seals, valves, switches, and other instruments with seals exposed to the oil. Finally, biodiesel has fewer BTUs per gallon than ultra-low sulfur diesel. This means that you're going to burn more gallons of fuel to get the same horsepower out of your boilers or the same kW output out of your gensets. Diesel fuel higher heating value can vary by up to 1% for each truckload. But because of the wide variety of feedstocks that go into biodiesel, the higher heating value range has been shown to be a little wider than with diesel fuel. These are the properties of the various biodiesel diesel blends, including ultra-low sulfur diesel, B20, B50, and B100, or pure biodiesel. Again, I apologize for the football units. And remember, there are error bars associated with all these properties because the blend can vary a little bit and still meet the ASTM specification. I've been told to pause on some of these tables in case somebody wants to do a screenshot or a snip. So what is the status of regulatory issues with biodiesel? Most ultra-low sulfur diesel already contains biodiesel. ASTM D975, which is the standard for ultra-low sulfur diesel, allows up to 5% biodiesel and the provider typically isn't required to disclose the biodiesel amount in the fuel. Several states, however, require that fuel delivery companies disclose how much biodiesel is in each truckload or each delivery of biodiesel, but that's a state-by-state requirement. Ultra low sulfur diesel has lower lubricity than low sulfur diesel. So part of the reason to blend in some biodiesel is to restore the lubricity lost when ultra low sulfur diesel was mandated to become ultra low sulfur diesel. B5 is very common, and most industries have not seen a problem with corrosion or swelling of seals related to B5. Preferred burner and fuel system technicians aren't seeing issues with customers using B5 either. Winter blends typically contain less biodiesel. Biodiesel has a higher cloud point than diesel, so part of winterizing diesel fuel is to reduce the amount of biodiesel blended in with the diesel. So what is the status of the technology around biodiesel storage, handling, and use? Preferred and a few of the main tank suppliers have tried to be ahead of the curve and offer equipment rated for B100. Preferred offers complete fuel systems guaranteed for biodiesel blends up to B100. This includes the pump sets, day tanks, polishers, and all the accessories that go in between. You do need to specify biodiesel compatibility when you order from Preferred. Our standard fuel systems include brass and bronze components, but we replace them when we're designing for biodiesel. Very soon, our equipment will have unique part numbers for the equipment that's guaranteed for biodiesel. With the burners, there are fewer components that need replacing for biodiesel. The concern is more about the combustion aspects of burning biodiesel than chemical compatibility. The BTU content and viscosity of biodiesel are a little different than ultra-low sulfur diesel, and this affects the sizing of the pumps, the fuel trains, and flow control valves. Also, the amount of air needed for clean combustion is a little different, so this needs to be taken into account with the fan sizing. The differences aren't large, but we just need to make sure that we do the math and make sure that, if we're real close to the next pump size, the next flow control valve size, or the next fan size, that it can accommodate burning biodiesel. Our technicians have a good deal of experience burning biodiesel and biodiesel blends. Preferred burns a biodiesel blend in our 2 shop boilers, and Preferred technicians take care of our boilers when they're not on a startup at someone else's facility. So what's the status of regulatory biodiesel requirements? There are lots of incentives to burning biodiesel and also for buying vehicles capable of burning biofuels. There's a convenient website that lists all these incentives and requirements broken down by each state. We've listed the URL here if you want to screenshot it. For some reason, PowerPoint didn't recognize it as a URL, so it didn't underline it, but it's all right. I've made a summary of the biodiesel use requirements for us to go over. First, the feds. Although there are a lot of federal incentives for producing and using biodiesel, there are no federal requirements to burn biodiesel. Note also, the price of biodiesel for heating is subsidized by a very complicated system whereby fossil fuel refiners are forced to subsidize biofuel producers. Chevron sort of got around this subsidy last year by purchasing REG, the largest US producer of biodiesel. So now Chevron subsidizes a unit of Chevron. It sounds like something the Pelosi family would be profiting from, but the end result is the price of biodiesel is artificially low to encourage its use. So now on to state requirements for biodiesel use. Arkansas and Louisiana require B2 fuel for all vehicles, so 2% biodiesel blended with ultra-low sulfur diesel. In Colorado, state-owned vehicles must burn at least B20. In Illinois, government-owned vehicles must be fueled with at least B5. In Indiana, Iowa, Kansas, government-owned vehicles must be fueled with at least B2. In Maryland, at least 50% of state-owned vehicles must use B5. Minnesota makes it really complicated. Their summer blend for all vehicles must be B20. Winter blend must be at least B5. And they even in April, during like the shoulder period, for a month, the blend has to be B10. So Minnesota makes it complicated, and they apply it to all diesel fuel sold in the state. So Minnesota is actually one of the most one of the most one of the states that's promoting biodiesel use the most. In Missouri, at least 75% of the Department of Transportation vehicles must burn B20. In New Hampshire, all of their Department of Transportation fuel vehicles must be B5. In New Jersey, state agencies must use biofuel. Uh, it doesn't say what kind of biofuel. It just says state agency vehicles must use biofuel. So I don't know if that's B100 or if it's a blend or what. In New Mexico, all vehicles fueled for state agencies must be B5. In North Carolina, school buses must run on B20. In Oregon and South Carolina, all diesel sold in the state must be B5. Pennsylvania is another state that makes it complicated. As state production, meaning as production of biodiesel in Pennsylvania ramps up, a higher blend of biodiesel up to B20 will be required for all diesel fuel sold. So the statute in Pennsylvania actually says, once Pennsylvania can produce so many gallons per day of biofuel, then the standard would be upped from B5 to B10 to eventually topping out at B20. In Washington, 2% of diesel fuel sold must be biodiesel, and that's 20% for state agencies. So really, when you think about it, there are no federal requirements for using biodiesel, just incentives. And although it's a mishmash, there really aren't a lot of state requirements for biodiesel use as well. Although I think this is going to be changing pretty quickly. We're going to cover that in a minute. You can see also the requirements for biodiesel don't fall along party lines like you might expect. California and New York State have no requirements for biodiesel at all. New York City is the only local municipality I'm aware of with its own biodiesel requirements. Since July 1st, 2022, New York City has required all heating oil to be B5, but this is really keeping up with what the fuel industry was already doing. Now in 2025, the requirement in New York City goes up to B10, and then by 2030, all diesel fuel used for heating needs to be B20. And several agencies within New York City are more aggressively pursuing higher concentration biodiesel blends than this. So one thing that was holding back biodiesel mandates for boilers was Underwriters Laboratories. Many new burners and boilers, and all burners in New York City, need to be UL listed. And UL just last month updated their standard, UL Standard 296, to cover burners up to B100. So because there wasn't a UL standard that really covered burners firing biodiesel, municipalities and states were hesitant to require that heating burners burn biodiesel. But all that has changed now, and I think it's going to open the floodgates to more requirements to burn biodiesel in heating boilers. So I thought that UL had only just submitted a draft for review of UL 2090 or UL 296, but it turns out they actually published it just a couple of weeks ago. So here are the highlights of UL 296 with respect to diesel firing. So burner components are subject to material restrictions and must be tested for corrosion and swelling, and it's a 1,000-hour test. The intent is to make sure burner manufacturers don't use any of the materials known to not play nicely with diesel and require them to test all burner materials for longevity. Fuel oil pumps must comply with UL 343. So this continues to mean that submersible pumps will not be allowed within New York City. I think City of Chicago is also the same. Their pump sets on boilers have to be UL 343. Cold fuel tests will be required for ignition and combustion. Biodiesel has a higher cloud point than diesel, so it needs to be tested at cold conditions to make sure the burners can light off and burn cleanly. All of the normal UL 296 combustion tests will still be required. Then there's a big requirement that's new, and I quoted it here. Without any adjustment to the burner, the fuel supply shall be changed from B100 to number 2. Because biodiesel has fewer BTUs per gallon than diesel, this means burners firing B100 must either be tuned lean to accommodate future number 2 oil, or include a feature that can automatically compensate, like O2 trim. This is actually really smart on the part of UL, because it anticipates the situation where a burner tuned on B100 needs to be switched to burning regular diesel in the event the facility can't get a delivery of B100. And for the foreseeable future, B100 is going to be much less common and less available than ultra low sulfur diesel. In the event there is a severe supply chain disruption in the production of, or delivery of biodiesel, there aren't going to be enough burner technicians to give everyone switching to diesel a retune. So my interpretation of this is that the burners must be tuned lean on biodiesel so that they don't smoke when firing diesel, or they have to have a control system that can automatically accommodate burning both fuels. This question comes up every time I talk to facility people about burning biodiesel in their boilers. They don't want to be stuck burning biodiesel in case they can't get a delivery. They want to make sure they can always go back to firing number 2 oil in the event biodiesel isn't available. Preferred offers a bunch of different control systems with oxygen trim that can automatically compensate for the different BTU content of biodiesel versus regular fossil diesel, including our BurnerMate TS, our BurnerMate Universal, our newer FlexFit controller, and our really older Utility Saver. These systems work by including an oxygen analyzer in the stack that compares current oxygen levels to the set point oxygen levels determined the last time the boiler was tuned up. And then it adds or subtracts air to get the stack oxygen back to the set point. Now that UL has updated 296 to include B100, I expect we're going to see a lot more government agencies ramp up their plans to require facilities to burn biodiesel. Finally, let's talk about the long-term concerns of storing biodiesel. To start with, it's important to understand that both diesel and biodiesel are subject to chemical decomposition over time. This is an oxidation reaction that begins as soon as the fuel is refined. A lot of facilities will burn and replace their fuel fast enough to keep it fresh, so chemical decomposition is not a problem for them. Adding a fuel stabilizer can greatly slow fuel degradation and extend the life of the fuel. Preferred on our representatives offer fuel stabilizers, and they can be added to our fuel polishers. Chemical degradation is important, but by far a larger concern is the accumulation of water in main storage tanks. These tanks are required to be vented to the atmosphere, and under certain conditions, the inside walls of the tank will condense water. The water is heavier than the fuel, so it will go to the bottom of the tank where it will sit. And it'll have fuel on top of it, so even on a warm, dry day, once that water gets to the bottom of your tank, it's never going to evaporate out. Also, the supply lines for your burners or your gensets should typically be up 6 or 8 inches, and hopefully the water doesn't get up to this level. But when you add more fuel to the tank, that water is never going to go away unless it gets sucked up by the intakes for your burners or your gensets, which is really the last thing that you want. Microorganisms live in the water that accumulates at the bottom of these storage tanks. They eat the fuel and they poop a biosludge that would clog strainers and fuel injectors. The microorganisms also produce organic acids that speed corrosion of the tank and fuel system components. Preferred series of PF polishers remove all water from the fuel, and they filter the sludge down to 10 microns. Actually, our standard filter element is 10 microns. You can replace it with any size filtration element you want, or whatever your gensets require. The suction line for the polishers is piped to the bottom of the fuel tank where water and sludge settles. We recommend the suction line be on one side of the tank and the return line on the other side of the tank to help promote mixing in the tank. That way you don't get any dead spots in the tank where you'll have fuel that isn't getting polished. If your tank has a low end, like most tanks eventually do because they settle, locate the suction pipe at the lowest point in the tank. When preferred engineers are consulting on the design of new fuel systems, one of the most common questions we get is, should this facility's fuel system include a polisher? We would love to see every fuel system include a polisher because it ensures the facility will never have a problem with fuel quality. But polishers are pricey, and honestly, a lot of facilities can do without them. Factors to consider including the amount of fuel consumption versus the total amount of fuel stored. If a facility is going to turn over a lot of their fuel and keep it fresh, they likely do not need a polisher. Facilities where high humidity and big temperature swings are common are going to accumulate more water in their tanks. Indoor tanks are going to accumulate much less water. I flew from Dallas to New Orleans yesterday on an early morning flight, and in both cities the ground was wet, but not from rain, but just condensation. It'd been cool for a couple of days, and then we got a batch of very warm, wet air in for the Gulf of Mexico, and that warm, saturated air hits the cold concrete and just condenses. And the same thing happens with cold steel tanks and cold fuel. It's rare, but sometimes you get a delivery of bad fuel. Nuclear plants have backup diesel generators, and nuclear plants test each delivery of fuel while it is still on the truck, and they sometimes reject a truckload of fuel, usually due to fuel clarity issues or sometimes because of water found in the fuel. So it's very unlikely, but it is possible to get a bad batch of fuel. Biodiesel is much more hygroscopic than fossil fuel diesel, meaning it is better at catching water vapor. So tanks with biodiesel in them tend to accumulate more water than tanks with ultra low sulfur diesel. There are other operational symptoms that your fuel tanks are accumulating a lot of water and can benefit from a polisher. These include your operators are frequently dumping strainer baskets. Genset strainers need frequent replacement. And you got to look at what's in these strainer baskets. Sometimes you'll find construction debris. You know, if the pipe wasn't cleaned out really well when it was put together, you'll get little burrs and weld slag. Sometimes you get little pieces of Teflon tape or pipe dope. But biosludge looks really different, and if you're getting biosludge in your strainers, that's an indication that you've got water in your tanks. If you bottom sample your tanks from time to time, like you should, look to see if they've got water or sludge in them. This is something that preferred technicians do whenever they do a preventive maintenance on a fuel system, is take a bottom sample of the tank and look at what's in it. If your burners or gensets are tripping due to clogged injectors, you likely have a water issue in your tank. We had a facility in New York City recently that actually had a duplex strainer, so they had two strainer baskets, and one of them's completely clogged, so they switched over to the other strainer basket. It didn't take long for that one to completely clog, and then once that strainer basket was clogged, the pumps couldn't get any oil, and the burners tripped on low oil pressure. And Our technicians did a bottom sample on their tank, and it was absolutely full of sludge. So these are all issues that a fuel polisher will likely fix. So thanks for sticking around to this webinar to the end. With UL 296 being updated for B100, I think we're going to see a lot of municipalities kind of up their plans to require higher blends of biodiesels for their facilities. And as you can see, Preferred is trying to be on the forefront of biodiesel fuel handling and combustion technology. If your facility is considering using biodiesel or is likely to have biodiesel forced on it, contact me and I'll put you in touch with a local Preferred representative who is knowledgeable about biodiesel storage, handling, and use. So we're going to take your questions now. You can put them in the chat box or you can email them to me directly. And thanks again for sticking around to the end.